we are going to get into our first speaker, our first presentation. So Brian Moran is a reliable, regular attendee of OSDFCon when it was in person. Sadly, we were not able to hang out as well. He's also been helping us out with the autopsy training. So for those of you who took the autopsy training and went through the data set scenario of the missing Renzik and trying to hunt that down, that was Brian's work that went into that. So he is now going to talk, though, about remote desktop connections and piecing together RDP sessions as part of ransomware and lateral movement investigations and a whole bunch of important things as part of forensics and incident response. So welcome, Brian, and take it over.
Well, thank you very much. I appreciate the introduction, and that was a very nice little smooth transition there from the split screen to the single screen. So we're already off to a fantastic start this early morning, so everything's looking good. So let's see, I believe everything is all set for the screen share. All right, so let's get started. So my talk today is going to be on remote desktop connection, the RDP Bitmap Cache, and specifically how that can play into your investigation. The title is obviously called Putting Together the RDPieces. I talked about this earlier in the year, which seems like about 75 years ago in the Magnet Virtual Summit. And this is just kind of updating where the research has gone since then. So pretty much a brief list of topics. Your investigations may involve RDP connections. They may not. Just breaking down kind of the evidence, the research and stuff with things, and then kind of get to the end of it. So who am I? So some of you know me, probably a good deal of the normal in-person attendees from OSDFCon most likely know me. For all of you who are virtual, probably not. So my name is Brian Moran. I spent 13 years in the Air Force. Of those 13 years, probably about half of that was kind of focused on the forensics and mobile investigations. Then I got out of the Air Force, transitioned to the commercial world, and have been doing that since 2011. I started my very own company in 2014 and have been incredibly happy doing that since. One of the other things that you may know me from is the hashtag D4Fit on Twitter. We started that several years ago as kind of just a way to kind of get people to be more active and be more involved and kind of just like get up and away from the computers for a little bit. At the start of this year, before all of the COVID kicked off and everything, we actually put together a virtual challenge with the help of my good friend, Kat Headley. And the whole goal was, again, to try to keep people motivated. So that has spawned into a whole series of now virtual challenges and everything. And so far this year, we've raised over $10,000 for a variety of charities with the D4Fit events. And yes, we're going to have one in 2020 or in 2021, assuming, of course, that we actually make it to 2021, which we only have 6 weeks to go. But those 6 weeks seem like it's going to be an incredibly, incredibly long 6 weeks. So what exactly is RDP? So RDP is essentially, to break it down in the very most basic way, it allows one computer to essentially make a connection to another computer, and you can do things on that other computer. It doesn't matter if it's in the same building, if it's in the next room, or halfway around the world. It essentially allows you to be on one computer and do things on another system. So why is that important in investigations? Like, again, some of your investigations may revolve around this, some may not. Typically what we see RDP used for is we see lateral movement in an environment once an attacker gets in. We see connections to known or suspected malicious systems or key systems such as the main controllers, mail server, stuff like that. We see it with regards to unauthorized access, and we see RDP quite a bit, unfortunately, in ransomware investigations. So how I got interested in this specific topic, like the RDP stuff I've known about for the RDP Bitmap Cache stuff, I've known about for quite some time, but like how I really got interested in it was, of course, there was a real world case which I worked, which really spawned my interest in it. So it was just pretty much a run-of-the-mill ransomware case, which unfortunately is pretty much what a large majority of the cases on the commercial side that we're currently responding to. And the difference in this particular one is the attacker actually cleaned up after themselves. So it was kind of strange because typically you don't see attackers actually cleaning up their tracks of stuff that they did all that terribly often. So they cleared kind of our regular go-to sources for data to piece back what had happened. So we didn't have event logs, we didn't have any of the recent data like the registry data was cleared, like everything was cleared. So it was really, really difficult to try to figure out exactly what had happened on the system. And of course, in the ransomware cases, we always try to figure out, the who, what, when, where, why, how. Was there any kind of data access? Was there any kind of data exfiltration? Like those are questions that we always have to answer in a ransomware case. And we didn't really have all that much to go on because all of the information was cleared. So fortunately for us, the attacker didn't clean up the RDP Bitmap Cache files. So we didn't have anything else to go on. So we made the decision, like, let's go ahead and dig into that. And I want to caveat this with Celebrite posted this GIF of Heather, I think probably 2 years ago. And I have made it my own personal goal that every presentation that I do, this GIF of Heather will be in it. So I'm sorry, Heather, except with the exception of you knew this was coming. So what exactly is the RDP Bitmap Cache? And if these slides later offline, if you want to dig into it, but pretty much in the very, very most basic terms, it's pretty much screenshots are taken during the RDP session, and those screenshots are broken into small little chunks and are written to disk on the endpoint that the RDP session originated from. And that's one thing that I absolutely want to note is just because there was an RDP connection made to a system, that doesn't necessarily mean that you're going to find these RDP bitmap cache files, because the bitmap cache files themselves are saved on the disk of the endpoint where the connection originated from. So this is just an example for those who aren't familiar with it. This is the RDP, this is just the remote desktop connection. And pretty much this screenshot here of that system, with like the mouse moving with the RDP, like that information is saved in a screenshot, which is then saved, broken into small chunks and written to disk. So the location of those files have kind of moved throughout the years. Originally, there was even a different format. For the most part, probably you're going to deal with mostly newer Windows systems. So the typical path for those is found under the app data, local Microsoft terminal server client, cache folder. And within that folder, you will see typically it starts with cache, and then it's a number of 4 numbers .bin, and they start at 000 and incrementally work their way up. And again, both of these files are essentially small chunks of these little screenshots that are saved from the remote desktop session. If you're interested in doing a little bit more reading on it, here's just a couple of links. I mean, there are getting to be more and more topics on this, but there still isn't a whole lot out there. These are pretty much the most reliable ones that I've found. And of course, if there's anybody who has done more research into it and I left you out, like, I'm not trying to slight you or anything like that. It's just, these are the ones that I found to be the most useful when I was trying to go through and do my research and do the math and everything like that. So of course, on all of our investigations, like, we come across a problem, we try to figure out what the problem is, we try to come up with a way to solve it. And then once we actually solve that problem, then we typically go back and try to figure out, okay, well, can I do this in a more reliable, repeatable way and somehow make this even easier for myself? And I very much enjoy OSDFCon. I do my absolute best to make it every year. And of course, this is an open source project, so it makes sense. And of course, part of my joy from coming to OSDFCon is actually being able to see everybody and hang out and watch giant robots fight and have a giant stack of pizzas and just enjoy being around everybody, which will happen eventually. I have no idea when that's going to happen, but eventually we will all be able to get back together and enjoy everything again. And this was the photographic proof from that amazing night just before we watched robots fight. So we had a huge stack of pizzas and just hung out, and it was such a fantastic time. So back to the RDP stuff. So how do we get data out from these RDP bitmap cache files? Pretty much the first thing we have to do is we have to extract the raw data from them. There are a couple of options to currently do this. The most reliable thing that I found is a Python script from ANSSI. It's called BMC-tools. So if you're familiar with the RDP Bitmap Cache, I'm sure that you've probably used it. The one important caveat to note with this is you have to use Python 2. And the other caveat that I found with this script is the files, when they're extracted, are off by 4 bytes. Essentially, the 4 bytes are too long. So most likely what happened is they counted the 4 bytes that start all of the bitmap files. They probably counted it twice. Like, I can't say for sure because I'm not the one who wrote it. However, I did open a bug request. And in the meantime, until that actually gets addressed, I put a version of it, which essentially just does the slight little change in the math in 2 lines of the Python code. I did put an updated version up on the RDPiece's GitHub repository, which is under my name there, and it'll be later in the presentation too. So until that gets fixed, like, I highly recommend just using that. It doesn't make a difference with the actual files or anything like that. It just does make a difference if you rely on other programs to process and do all of the mathiness and everything related to that. There's also a PowerShell option that I found that's available to extract these files. My solution that I'm going to talk about here throughout the course of this talk does not currently support the output of that because they're PNG files. However, if enough people do use that and want me to actually work on something like that, I'm pretty sure that I can put some kind of solution together to automate that in the same sort of way that I went through this. So now that we have our data from the RDP Bitmap Cache files all done, and we've actually extracted the information, now we have to go through and see what we actually have. So more than likely, the folder structure probably looks something similar to this. Again, you have your cache with the numbers named after it. And then you have a whole bunch of small bitmap files that are all started with the cache name and then essentially starting from 0 and working its way up. And this is just an example of these little tiny small tiles. And, again, we see that it's a bunch of stuff that kind of looks like you can put maybe some pieces of it sort of together just by looking at it, but obviously it's not really in an actual like set order or anything like that. So it's going to make it a little bit difficult trying to figure out exactly how these pieces go together. So we've extracted the data. We ensured the data is all good and correct. It's like, so what do we do now? So we have essentially a whole bunch of small bitmap images that are 64 by 64 pixels and one huge bitmap file with all of them lined up, which we're going to show an example of the next slide. And one of the things that we could do is we could rearrange all of them and kind of hope to like rebuild these individual screenshots and, kind of move one from the top, one from the bottom, kind of move it around and hopefully be able to piece back together some things. However, I will say that is an incredibly challenging, incredibly tedious task. And another thing that was able to come out through researching all of this is that while typically these tiles are 64 pixels by 64 pixels, that is not always the case. It turns out that sometimes they are a little bit smaller. They are never larger than 64 by 64. However, when they're smaller, that brings the whole kind of like consistent mathiness into all sorts of other issues. And then that makes the reconstruction of it even more difficult. So this is an example of, this is just one RDP Bitmap Cache file, which has been completely rebuilt. And again, you can kind of see that some things sort of line up and some colors kind of go together, but there's just so much information here. It's like, it's really overwhelming trying to rebuild what happened with specific user activity based off of just all this information kind of just dumped and stored in this format for you. So this is one of my favorite gifts related to the RDP Bitmap Cache. It's like, it looks really awesome, it looks really cool, but like just because we make the and zoom in on the image and try to make it bigger, like that doesn't make it any better at all, because obviously resolution is based off resolution, and when we make it bigger, like that doesn't mean that we automatically have a solution. Like it just means that it gets bigger and we just see more of the pixels. However, the pixel thought will come into play a little bit with my solution process as we work through it. So one of the things that I try to do here is figure out exactly how we're going to do this. So we have all of these little slides, we have all of this stuff, and we're going to try then to kind of rebuild the structure, and hopefully we get an idea of like, like these pieces go together, this piece kind of goes here, this thing looks sort of similar to this. And you kind of rebuild hopefully a little chunk of it, and then you realize that like that whole chunk that you rebuild is completely wrong because something else is there, and then you just, after a while, it just becomes incredibly overwhelming and incredibly frustrating. And you just like, all of these pieces are all over the place, trying to sort everything out. And you have really no idea of where any of this goes. So eventually, though, you do come across some stuff and you're able to get some stuff. So in this particular case, we see that we have a domain, we have passwords, we have servers, we have all sorts of information that like, hey, this is actually useful for our investigation. Like we were able to get some really, really cool stuff out of here. However, the one caveat for all of this is it takes a long time because it's a lot of small pieces. It's a lot of kind of rearranging and rebuilding little things. And then you have to go through and try to figure out like, how am I going to work through all of this huge amount of information and rebuild all of this stuff and then hopefully get something usable out of it, but not take a ridiculously long amount of time to do it. So my whole goal for this was try to come up with an easier way, hopefully, to at least reduce the amount of information that you have to work through. And hopefully that will make at least rebuilding these little pieces of it easier. And then hopefully once you rebuild those little pieces, you can take a bunch of those pieces of it that are rebuilt and then hopefully put them together and kind of get a more holistic view of what's actually going on in this particular session. So this was pretty much my first thought, is like, I thought that I was going to have to do all kinds of just ridiculous math and have all of this stuff that was just like, had to just think all the way through it and figure all of it out. And yeah, so like Heather's GIF is one of my favorite GIFs. Like this might be my actual favorite GIF of all time, just because it like, I'm going to have to do some amazing stuff and just do all kinds of math. So in my former life, when I worked at a 3-letter agency, there are all kinds of ridiculously smart math people, which is amazing. However, I am not one of those ridiculously smart math people. So I had to try to figure out like, how can I do math in a way that's going to make sense to me, that is actually work, but don't have the huge mathematical background to make everything. So I started kind of mapping it out and figuring out like what I'm going to do, and kind of like starting essentially from scratch. Is like, how can I make this actually work? So, kind of like, oh, well, I have this little piece. And then after a while, like it just started to drive me crazy because there were all these different rabbit holes, all of these different things that I had to try to like go down and figure out like how it was that I was actually going to be able to do any of this properly. So fortunately, I found a tool that pretty much did a lot of the underlying math analysis stuff for me, because at the end of the day, any digital image is essentially an arrangement of pixels, and it's an arrangement of individual pixels, these individual tiles, and they are arranged and they have a color assigned to them, which means they have a mathematical value assigned to them, which means that hopefully, once you actually do some deep dive analysis on it, like you can figure out that some of these colors are very similar to other colors. And hopefully we can use all of that information of what a picture actually is and kind of rebuild this stuff, hopefully in a way that actually works. So ImageMagick was a huge help with regards to kind of doing all of the underlying math stuff that I was just constantly trying to figure out how I was going to make it work. Like it did all of that and honestly quite a whole lot more. And since it did that, it's like, I'm going to rely really heavily on this. So now that I had the part of figuring out where exactly like kind of the math part of how I was going to make that work, then I had to take into account, like, how do I make this wide enough to actually match properly, but also narrow enough where it's not gonna include like everything that is very similar, or have too much information or not enough. So, just had to come up with essentially like ways to kind of make it work and make it work in a reliable format, but didn't want to make it over or too wide ranging so that it matched on everything. And I will say Python absolutely sucks for doing anything that is ridiculously hard math related. Those who know me know that I came up with a huge Perl background, and Perl handled all of the mathiness with no problem. I threw a couple of math problems at Python and the snake just threw up on itself. So this was written completely in Perl, and it will always be written in Perl because Perl handles all of the math stuff amazingly well. So now that I had a kind of an idea, a thought process with regards to like, okay, I have my math stuff, I have my pictures, I have my information, like how can I do this in the most efficient way properly? And, again, this kind of goes back to a conversation that I had actually yesterday with Jessica Hyde on her Cache Up, with regards to everybody has a different background and has different experiences. And in this particular case, one of my hobbies is digital photography. And working with the information in that kind of helped spur me along with regards to how I was going to actually make all of this work. And I'm also not going to lie, like alcohol helped immensely with regards to how I was going to do this. Like I fully believe in the Balmer peak. There is this exact number of some point, and it's not necessarily 0.138-ish or so, but there is some point where essentially you are able to completely get out of your own way and actually let your brain solve the problems that it's supposed to solve. And you don't, you essentially are just subconsciously doing it. And at the end of the day, you have an amazing result. So this, going back to the putting the pieces together, like with a puzzle, like generally you kind of look for shapes that sort of go together, and then the shapes and colors are determined by the edges. And then you kind of start looking at that and start going like piece by piece. And essentially you don't rebuild an entire puzzle at once, you rebuild it kind of one piece at a time. So thinking about that as like, this might actually work, like looking at this as an actual puzzle and kind of rebuilding this with the input of math, like I think I can actually somehow make this work. So rather than looking at the entirety of an image, because the pieces are going together on the edges of each of these images, it's like, well, what if I just look at the edges and try to come up with some kind of like color variant, standard deviation, how many colors were done, maybe a little bit with regards to like file name spatial, the file names themselves, like maybe I could generate some sort of data. And initially I started looking at a much wider swath of the file, and then kind of working my way down. And it seems like 5 pixels is kind of the perfect median, the perfect median with regards to if I'm matching a top, bottom, or left or right. Like I'm just going to take a little 5 pixel slice. I'm going to do some math on it. And then hopefully that is going to allow me to put the pieces together with regards to that. And admittedly, like this is not perfect. Like this is not a perfect solution by any means. But since the whole point is to kind of automate this process and make the amount of data that we're going through, like it's a really good start. So what I did is I used ImageMagick to make a total of 4 new files from each of the files, and I took my slices from the top, from the left, or from the top, bottom and bottom, the left and the right. The script now has also been updated to work for numbers that are less than 64, since we don't always have the 64, since they're always not 64 pixels in length. Then I push all of that stuff to a SQLite database that's stored completely in memory, so that way I got the results out faster. And the formula that I'm using for all of this, like it still is evolving. Like I always want to try to work on it and continue to refine it. And the one thing that I will say is since all the mathy stuff is all pushed towards the SQLite database, like it's a whole lot easier building SQLite queries rather than trying to figure out more mathematical statistics about the files and everything like that. So what I wrote was a script which was called RDPieces.pl, which has been updated and uploaded to GitHub, I believe. Late last night, early this morning, I pushed the latest version up. It will completely work cross-platform. It works on Windows, Mac, OS, and Linux. I'm not necessarily sure that it works on Big Sur yet because I haven't updated to Big Sur, and I don't plan on doing that anytime soon. It should work. However, I'm not going to guarantee that it does. I also can't necessarily guarantee it works on the new M1 processors because I haven't had a chance to buy or test that yet, but it should. So if it doesn't, hopefully you can find a system that is actually one of the not the latest and greatest Mac offerings. It does require the ImageMagick tool itself to be installed, and then the script also does clean up after itself, deleting the temporary data directory while they slices. And at some point, like I would like to make a cool logo for it. As you know, like I make a bunch of cool logos for stuff, and I really want to do that. However, this year has been an incredibly busy year. So hopefully once the ransomware cases slow down, like I'll be able to have time to do more development and do more things like make cool logos and do more things that are more fun stuff rather than dealing with ransomware cases. So in the testing, there's approximately 400 results that you get from each of the bitmap caches compared to roughly 6,400 files from them. So instead of having to go through 6,400 files, you have to go through 400 slightly larger files and hopefully be able to rearrange and put them together and everything like that. One of the things that I did is I also took the rebuilt image And I saved all of the original files that were used to create that image because, again, because it's math, it isn't necessarily perfect. However, hopefully, if you have a smaller amount of files, like if you have 20 files to look through rather than 6,400 files, you're able to take those and rearrange those and hopefully build something out in a more usable picture rather than try to figure out where exactly these files are in this huge chunk of 6,400 files, and then work your way through that. And doing this is much, much easier, of course, than doing it manually. This is just an example of the script itself as it's running through. Again, pretty straightforward. It tries to make sure that there are enough colors, because we do need some color variants. And if there aren't enough color variants, it just moves along to the next file and skips it. And this is just a slightly enlarged version of it. So again, you can see that the output as it's running. When it gets all done, it tells you that it's deleting the temporary directory, tells you the number of files, and then then also tells you exactly how long it took to run. It's fairly quick. It's based generally off of the size of the cache itself, but usually it runs in a fairly quick manner. And this is an example of our output. So we have our left-right file 154. We have our left-right file at 154 bitmap. And then in that folder, we have all of the individual files. And as we can see here, like, this isn't necessarily perfect, like it's by no means perfect, but we can already look at it and get some idea of what is happening in this particular image. And we might be able to actually make some actual sense out of the information that we see. So we take the original image, which is at the bottom of the screen, and then we kind of rearrange it and sort of build off what would be kind of the information in the screenshot itself. And we're able, not necessarily, again, to get a perfect solution, but we can see from this that there is some information that we can get from it. And again, because we had those original files, we can go back and kind of redo the individual files and kind of rearrange them as we need to do. So this is an example of a couple of slices that were analyzed with the script, and then we're able to go back through and put all of them back together, rearrange all of that, and now we have a little bit. So we see that we have a command prompt window open. We see that they ran the IP config command. We see that we had packet loss, which suggests that the computer may not actually be online, or the network adapter itself is not online. So we're able to get some information that we wouldn't have been able to get otherwise, just from going back and kind of rebuilding or rearranging this information from the RDP Bitmap Cache files themselves. So it's not perfect. It's not meant to be perfect. Eventually, like, I would absolutely love it to be perfect, but I don't know that I will ever acquire enough math knowledge to actually make this a completely perfect solution. But again, we can see that things have happened on the system. We can say that the attacker did some certain things, and we have some great information. So it's fantastic. So this is a continuing project. I publicly released this back in I believe it was May for the first time, and have been dying to get back and try to kind of refine it and rebuild it more. The one thing that I will say is, like, it's entirely open source, and I entirely want to always keep this open source. And I specifically wrote the license that way. So, like, commercial tools can use it, but, like, they have to make sure that their part of using this, like, remains open source, because, like, this is a problem that we as an entire community see, that we as an entire community are coming together and trying to solve. And I never want to see this information, like, be closed source and just be paid for, because we're a huge open source community. So, like, let's try to keep this open source. And if Microsoft isn't going to release the technical details, like, hopefully we can get enough brain power and figure out a solution that is actually viable and actually works long term. You can download the script here again. It's on my GitHub page. And again, like, I want to keep this open source. I always want to keep it open source. Like, I am always open to any feedback, any thoughts, any development, anything with regards to trying to make it better. And to be completely honest, I'm not quite sure why. Oh, it's the sharing carries caring. I was wondering, like, why did I put the GIF of the dogs chewing a bone together? That's why, because the dogs like each other, and the dogs cared about each other. So this is just an example of the README on the GitHub page. Again, pretty straightforward. Done with regards to how it works, everything like that. Pretty much, again, tries to be self-explanatory as much. And my good friend Heather pretty much described this as the best way. She's like, it's an adult jigsaw puzzle, but for forensic analysts, and that is absolutely the case. And she also said it's kind of relaxing, which I don't necessarily agree with, because I don't feel like it was initially kind of relaxing. It was incredibly frustrating and tedious, and led me to question all sorts of things about all sorts of other things. But it also leads me to question some things about her, because if she finds this relaxing, like it kind of scares me a little bit to think like what could possibly stress her out. And of course, we have to have a naughty by nature reference, except, you know, obviously they're talking about RDP. And yeah, that's pretty much all of it. So have my Twitter bio there. I feel free to send me an email. Once this gets all done, I'm going to pop over to the Discord and hang out in that. And I think that's pretty much all of it.
Brian, I can imagine here there's a thunderous applause if we were in a real room together.
I thought that was just in my head. That's amazing.
I do have a few questions, though. We have a few minutes. I have a few questions, and then we're going to. I grabbed some from the Discord channel. We can raise over as well. One, what is the Lance reference in the memes that are already in there? Can you share that? Is that public knowledge?
So during the SANS DFIR summit, we had a sort of breakout room, but it wasn't really a breakout room. And I wasn't aware that we were live. And Matt Bromley popped in. And every time I see Matt Bromley, there's immediate references to Tropic Thunder thrown out. And yeah, we were live to however many people they had. And I absolutely dropped an F-bomb from one of the quotes from that movie. And that is where that Lance reference comes from.
Wow. All right. Well,
so that hasn't happened here yet. Fingers crossed.
We have technicians behind the scenes who are with their fingers on the bleep button, ready.
I saw the command center. Like y'all have gone all out for this.
Second question is, when is the autopsy module coming for this? Which I just saw the Discord channel as well.
Yeah, that's a good question. Let's ask Mark McKinnon. Yeah.
We have a couple. We have a chance for a couple more questions. Let me see if I can see if you can answer some of them. We have one in here. What we have. One question was, by snapshots, do you mean something being captured? Hypothetically, say attacker gets to know your methods of forensics and cleans up after them. What then?
Well, so the one thing that I have noticed an evolution of is ransomware is typically now also will encrypt .bin files, which renders these useless. You can also, I don't remember what the setting is, but there's also a setting you can invoke in the registry to stop the RDP bitmap caching. And these screenshots, we don't know why Microsoft does it. My thought is because essentially when you switch windows, when you're in Windows and you essentially tile from like one application to another, I think the reason that this is done is so that way you can switch to essentially that RDP session, so you have an idea of what it is. Now, I can't say that for certain on why exactly that's happening and if that is the reason, but there is some reason that Microsoft is capturing essentially these screenshots at random increments. Like we don't even know what the increments are of when these screenshots are happening, but these screenshots are happening, being broken up in these small pieces and then being stored to disk for whatever reason. Like, I don't know exactly why Microsoft does it. I don't know if we will ever know why Microsoft does it. However, I will say with regards to attacker methodology, like typically an attacker will do only as much as is needed to get into your environment, and they will only do as much as needed with regards to cleanup. So if they clean up if they specifically go and clean up these files, like obviously then you don't have as much oversight into it. But in most cases, that does not occur unless the ransomware itself is looking for things like the .bin file. So it's not necessarily kind of worried about attackers learning the forensic analysis methodology. It's more along the lines of how lazy and how lazy are the attackers and how thorough are the attackers, and that's pretty much the question.
Yep, great. Great, thanks. There's a bunch of other questions in there and a bunch of banter and chatter and various other things. Including a question about integration to cyber triage as well. So we can talk about that later as well. Okay. So thank you very much, Brian. Appreciate that. Great way to kick off the event. And so thank you very much.
Great. Thank you.